Hi folks, I'm Christian. I'm a product manager at Google, and I am going to be talking a little bit about WebAuthn, web authentication today. Kind of weird, it's a Android talk, but we're talking about the web. It's because WebAuthn or FIDO also have some great kind of corresponding functionality directly in Android that I want to introduce here today. I changed the title of my talk a little bit to like an introduction to WebAuthn and Android because I rather want to go kind of a little bit more on the horizontal side than going too deep, because I have a feeling that WebAuthn and FIDO is maybe something that a lot of folks here have perhaps not spent as much time on as at some of the security and conferences like Black Hat and DEF CON where I normally present the material. But before that, let me maybe ask the question by a show of hands, who here has heard about FIDO or WebAuthn? Okay, then I think I'm good with my introduction material. All right, great. It's going to be pretty technical because I know this is a pretty technical group, so it's not going to be like marketing and other stuff. It's going to be a kind of like a technical introduction, but I'm kind of going to go a little bit wider than I would normally go in a talk like this. Feel free to follow me on Twitter. I have too few followers. All right. I'll show that again later. The agenda today, what we're going to be talking about here is, and I normally like to move around, so I'm sorry I need to stand still for the camera, so that's kind of a little bit awkward, but we'll try our best. So the agenda today, three things we're going to be discussing. First, passwords are broken. We've all heard about Passwordless. I would imagine, I'm not going to ask the question, but I imagine if like I ask folks to kind of put up their hands for like, who's heard about Passwordless and to move away from passwords, probably all of us, right? I mean, passwords kind of suck. We want to move away from them. And WebAuthn and FIDO, the stuff that I'm going to talk about today, we think is the best chance that we've had so far at actually moving away from passwords for once and for all. I don't think I'm going to get to it later, so I'll say it now. The work that I'm going to be talking about here today is also work that all of the platform vendors are working on. So in other words, it's Google work, it's Apple's doing the same work. You might have heard Apple refer to their version of this as Apple Passkeys. Same thing, it's all FIDO and WebAuthn. So the same thing is happening on Apple's platforms, both iOS and macOS. And then Microsoft, of course, is also very, very involved on the desktop laptop side. So this is kind of like a cross-industry collaboration for the first time. It's kind of like a holistic move. It's not like a specific thing from one company. You know, with hundreds of companies kind of combined forces in this thing, but probably for the purposes of the implementation, the most important ones are the Apple, Microsoft, and kind of Google angle. So we're going to be talking a little bit about passwords and how they're broken. We're going to be talking a little about the emerging passwordless near future, what that means, what the technology can do, and where we're heading with this stuff. Not everything is fully baked yet, so you're getting a bit of a preview of what we're going to be doing over the next year or so. So that might be interesting as well. And then lastly, we're going to look at a little bit of real-world data, right? This is all stuff that I think intuitively we all know. Users like biometrics and other things much more than they like passwords. So we'll be talking a little bit about that and looking at some data. So first, passwords are broken. The problem that we set out to solve back in 2010 is one that has to do with phishing. I'm pretty sure you're all familiar with phishing. Phishing is kind of the scourge of the internet. What we've had in the past and what we have today looks slightly different. Back in the day, we had malware. Like, malware is bad, it's everywhere. It's kind of like hard to perpetrate. Hackers have figured out that you don't really have to write malware anymore and put it on people's machines. You can just trick them into giving your password away to them. It's really easy, right? You set up a website, looks just like Google, looks just like Microsoft, whatever, right? Facebook, and you trick a user in going there. The URL doesn't even match up. Like, the URL says fakefacebook.com. No one reads it, right? They click, they type in their password, and hey, the hacker now has your password. The industry have tried to solve this problem by doing, you know, things like multi-factor authentication, two-step verification, whatever you want to call it. The reality is that that still doesn't solve the problem, because if a hacker can trick you into typing your username and your password into their website, they can trick you into typing your OTP code in there as well. There's no reason why they can't do that, and they've actually been actively doing that. And technologies like push authentication and other stuff that has come since all suffer from the same kind of fundamental flaw, where an attacker can trick you into approving a prompt on your phone, and actually you're allowing them to log into the website. I'm not going to get into that in too much detail, but that's essentially kind of what we've been seeing. So even technologies like Google Prompt and other types of multi-factor authentication things that we're doing for our users' accounts, those things fundamentally are phishable at scale, kind of depending on, you know, who the attacker is and what they're doing. We, of course, are, you know, we have a whole reputational system where we're trying to kind of like move away from just allowing anyone to come in and perpetrate phishing on a website, but still the challenge remains. And if you're building an app that deals with some kind of sensitive data where you want to do user authentication, phishing is a real challenge. And actually, I pulled this data right before the safe browsing transparency report that we have online stopped tracking malware and phishing individually, because there's no point anymore. Most of it is phishing, so we kind of just have one single graph right now that shows you the bad websites on the net. So we wanted to solve this problem, and we wanted to solve this problem for Google. First and foremost, Google had an event back in 2009, 2010, which kind of like is pretty well known, and kind of the same thing that happened to Twitter lately, right? A bunch of bad people kind of like try to get in, and usually how do they get in? They get in through phishing. So we wanted to solve this phishing problem for our internal network. We wanted to solve it for staff, for our own corporate networks. And we kind of like looked at different types of technologies and things that we can deploy. And in the next slide here, you'll see kind of like the basic building blocks of what we invented at that point, together with a bunch of other companies. And we thought it was so cool that we wanted to bring that to the larger web and kind of like to the larger ecosystem, not only web, but actually ecosystem stuff. So we'll see that as well. But what was born at that point was this alliance called the FIDO Alliance. FIDO stands for Fast Identity Online. And out of that kind of like came a web standard in the W3C called WebAuthn, or Web Authentication. And although it's a web standard, there is complementary APIs on all of the native platforms. iOS have their version of it, Android has its version of it, and then Microsoft has their kind of Windows native implementation of WebAuthn as well. And then, of course, you can access the stuff through the web as well. So there's a nice parallelism here where you can access the same things from the web, and you can access the same stuff natively in the platform as well. So there's kind of like two parts to all of this. There is a API between a server and a client. The client is kind of like the mobile device or the device that the user is on, and that is governed by this W3C WebAuthn API. And then there is a second API that's kind of like governed by this body called the FIDO Alliance. And that one is wholly uninteresting for the purpose of this discussion. That normally governs how, physical security keys. I'm not sure if you've kind of like seen these or heard about them. Physical security key is one way in which you can deploy this WebAuthn technology. We'll be talking about other ways in which you can do it as well, where you don't need physical keys distributed to users. But this was the first instantiation of the technology. It was, let's deploy physical security keys. Let's give every employee a physical thing. This thing can do crypto. Nowadays, the phone will just do the crypto, but the idea was that this thing can do cryptography. This thing has some, secret material in it, and we'll talk about what that is in a second. But we needed a protocol for this USB device to talk to a laptop, right? To talk to the phone, to talk to the thing that you plug it into. That protocol is governed by the FIDO Alliance. Only really interesting if you're going to make some of these keys. However, the W3C API, the one between the server and the browser, or in the case of Android, the Android API, which we'll talk about, that's the more interesting one, which is how a developer would interact with this API. We'll get to more of that. We talk about WebAuthn and FIDO sometimes interchangeably. So the slide here is just kind of like another representation of what I just showed in the previous slide. There is this thing called FIDO2. FIDO2 is the protocol. It's kind of like almost like OAuth 2. It's like this top level construct. And under FIDO2 sits this W3C API, which is the more important one between the server and the device, and then this other, kind of like ancillary protocol, which has to do with how you connect authenticators into the FIDO ecosystem. But for the purpose of this discussion, we're mostly going to be talking about this right here, which is how W3C's WebAuthn API or the FIDO2 APIs on Android allows you to gain access to built-in authenticators, like the biometric capabilities of a phone, and even the screen lock, right? It doesn't have to be biometrics. Like the screen lock on the phone can also serve almost the same purpose as what we have with biometrics, but I'll talk a little bit more about that. So before we get started with any of this, let's quickly just go through how the protocol works. I decided to show this with a physical security key because it's a little bit easier to see and kind of explain, but you can imagine that that physical security key that I have here can just be a built-in, what we call an authenticator, built into the Android system, right, directly. So the thing that I said earlier on, this technology and this protocol was invented to address phishing, and we're going to look at how the protocol actually does that now. So the thinking here is that if a user wants to authenticate to a server, hopefully they're going to the real Google website. They might be on the wrong Google website. Who knows at this point? Because users certainly aren't going to check the URL bar. So what happens is the user tries to log into a server, give the server a username, give the server a password, and then the server says, well, I think everything looks good here, but let's make sure you're actually in possession of a physical device that identifies you. The thinking here and the theory is that at some point in the user's life previously to this event, they had their security key registered to their account, right? So you can buy these little security keys. They cost between $5 and like $25, depending on where you buy them. And this physical security key houses essentially a private key. So the thinking is that if you want to register the key with your Google account or your Twitter account or your Facebook account, all these services support them. You plug in the key into your USB port and you click register on that particular website. And what happens is a private key gets generated on the security key, and the public key component of that gets sent to the server. So the server on the other side now knows this public key belongs to this user, and next time you want to log in, we're going to make sure the user actually owns the private key. So typical, public-private key cryptography, where you're not ever revealing your private key, you're just revealing possession of it by signing over a challenge. But the cool thing about FIDO is you don't really need to know any of that stuff. Like, all of this is abstracted away in the protocol. So the thinking is you want to log in, so you give your username and your password to a server. Server will send a challenge. The challenge is just to prevent replay attacks. So it's making sure that it's fresh. It's just a random piece of data that the server generates, sends it to the phone, and it tells the phone, hey, you go make sure there's actually a security key attached here. So what the phone will do is it'll, via the browser in this case, it could just be Android operating system as well, it'll first identify hey, who's actually requesting this signed operation? Basically the URL bar of what the user is pointed to, or the name of the application. It's very, very important in FIDO. That gets passed along to the authenticator. So both the challenge and who's actually asking for the challenge gets passed to the authenticator. Again, this could be a physical security key, or it could just be the thing built into Android, which is the FIDO2 authenticator, which is almost like a built-in security key in the device. At that point in time, security key does a signature, so it signs over the challenge and over the origin, which is the app name, or in this case, the URL, or the host. And it then returns that signed challenge back over whatever protocol you have here locally. On Android, it's just an internal transport. Here, it's physical USB, NFC, or Bluetooth. Returns it back to the phone. The phone returns it all back to Google, and then Google looks at that signature, validates that it's valid, so it checks that it was signed with the right private key, because we have the public key, so we can validate that. It checks that the challenge is correct. It's the one that we sent to make sure there's no replay happening. And the most important of all, it actually validates the origin. So now for the first time, the server is absolutely 100% sure that the user was pointed to the right URL, or they were using the right app. There was no fakery going on. There's no other app that the user typed their credentials into. They were actually on the right app or on the right website, because we're signing over which application is actually responsible for handling this communication. And that was really the breakthrough with FIDO. It's very, very simple, but in essence, the fact that we include the origin for the first time made sure that the server is now in a position to validate what the user is actually looking at. So that's kind of like the big thing here, and that's why this protocol is so important, and kind of like groundbreaking. I think Twitter just published literally maybe yesterday an article on how they moved their whole internal corporate suite over to physical security keys for their own security. We at Google have done that a long time ago as well. I think back in 2014. We've moved all of our users over because if you are in a position where you want to make sure your employees can't be phished, it's really almost of no use to try and educate them. People will fall for phishing all the time. That just happens. The best way to protect is by kind of implementing some kind of a protocol or having some technical construct implemented, and that's really what we're doing with FIDO. Physical security keys, or the ones built into the device, which we'll talk about in a second. Okay, so that's enough about physical keys. We know physical keys are not going to take over the world. We're never going to have every single user on the planet carrying a key. Not going to work. So what can we do to use this cool technology that we've just looked at to do two things? Firstly, get it in everyone's hands. And secondly, how can we remove the reliance on passwords? Like, the password is kind of like still, in the previous example, you still type a username, type a password, and then use the key. How can we just remove the reliance on the password while making this accessible to everyone? So in essence, there's really two use cases today that's accessible to developers. The first one is the one I just spoke about, which is the username, password plus physical key, which is this use case number one. We call it the bootstrapping use case. And then we have a second use case, which is a little bit more interesting. And this use case is very, very similar to what we've seen for the last, I don't know how many years this is now, 6, 7 years since the iPhone 5S, where Apple introduced a fingerprint scanner on their devices. It kind of brought biometric authentication to mainstream use, right? We are all familiar with how you show your face or touch your finger to open an app. All modern applications that has something to protect the big financial institutions type apps have this functionality implemented in it. But usually, if you want to implement biometric security in your app, you have kind of two choices. The one is you call some API that just tells the system, show up this dialog and return me a Boolean and tell me if the user successfully touched their fingerprint. Not great for authentication remotely. Or the other option is if you want to do it properly, you have to do everything yourself. You have to make a key pair, you have to put it in a key store, you have to set the right properties on the key store, and then you have to do a signature and then send it to your server, and then you have to do validation on the signature. A lot of work to actually do this properly. So FIDO abstracts all of that away. So the thinking is, if you want to do biometric authentication in your app, you can, instead of doing all of that stuff I just spoke about, you can literally be calling the FIDO API. And we'll look at the FIDO API in a second. You pass in a couple of parameters and everything else is taken care of for you. It's generating a signature in a standard format. On the server side, you still need to validate the signature, but there's a bunch of open source libraries and implementations that you can use on the server side to do that FIDO validation for you. Some are open source, some are commercial, but the point is you don't have to do this yourself, and the chances of making a mistake in the validation here kind of moves away, and it also incentivizes folks to rather do biometric or at least cryptographic-based checking and validation rather than just passing a Boolean back and forth. So that's kind of like the idea. Of course, the big benefit of using WebAuthn here is that not only does it work in apps, it also works on web. So if you're kind of running a website on Android or on any platform supporting WebAuthn, you can now have biometric authentication on the web, right? This also works directly from the web. You don't need to do it only in an app. So if you're an app developer, maybe that's not so important to you. But the cool thing is, imagine this. You have a, let's say I'm from the States, Bank of America app, right? You've got a Bank of America app running on your phone. You've registered your biometric to it. That's how you sign into the app. If you move to, if you open your Android Chrome browser on that particular phone and you go to the Bank of America website, you can use that exact same fingerprint that you just registered over on the app. You can use that exact same key pair and key material in the website as well, because the publisher of both the website and the app is the same, and we use asset linking for that. I'm not going to go into too much detail there. That's how we link these things behind the scenes. But in essence, because the publisher is the same, the key material is shared. There's shared context here. So if the user already successfully enrolled over in the app, they can use this data in the web, and vice versa. If a user have registered their biometrics on the web, you can use that actual key material over on the application as well. Just one point here, we're not actually registering a biometric, but I think folks get that. The biometric always stays local on the device. We're registering a key pair, and that same key pair is accessible by both your app and the website. So that's some kind of a nice use case, but I'll touch on that a little bit later. So how is this implemented on Android today? So today, if you have an app, right, if you have an app running here, you have multiple choices in interfacing directly with the keymaster on Android. You can also interface directly with biometric prompt, which is the new way of doing biometrics on Android. Or now you have this blue arrow, which means you can talk directly to the FIDO module. And the FIDO module is almost like an abstraction on top of all this stuff at the bottom layer. So if you don't want to interact directly with this stuff, interact with the FIDO module. And there's this other blue arrow, as I just said, from Chrome, or whatever the favorite browser on the system is. It doesn't have to be Chrome. It could be Edge, right? It doesn't matter. Firefox. Any browser on the system can also access the FIDO module, which means if your users go from the app to the web or vice versa, that same key material remains accessible. So they can be authenticated without having to log in from scratch again. If they've registered their fingerprint in the one thing, they can be using it in the other, or registered their key pair essentially, and they can be using it in both places. In a second here, we'll see how this actually even extends beyond the phone. What if your user uses your app on the laptop on the phone, and tomorrow they want to go to your website on their laptop? There's a mechanism with FIDO where that key material that's on their phone can now be accessible from the laptop by using a local protocol between these two devices, which is what we're working on, which I'll show you in a second as well. So anyway, so the thinking here is, if there is one thing to take away here, FIDO module on Android, take a look at it. That's kind of where it's at. And then of course the FIDO module could also talk to external keys. So if your app has a requirement for stronger security where you want to enable an interface with external devices, you could do it. But mostly for the purposes of the discussion here, we're going to assume that the FIDO module will be using the local authenticator over here, which is implemented using a combination of keymaster and biometrics on the device, or Strongbox, or whatever you have on your favorite Android phone. Strongbox is the newer implementation on some Pixel devices that we've got using the Titan M chip. So all of that stuff is linked into the FIDO modules. You don't have to do any work. You just call the FIDO module and it abstracts everything else away for you. So let's talk through some use cases. So Eliza is going to be kind of like my user or persona here for these couple of use cases, which we'll step through briefly just to show you what's possible with FIDO today and where we're heading. So let's say Eliza wants to sign into your bank app on Android, right? So I use bank app here because it's a canonical example of something where you want to be signed in and there's some security properties that you want to keep. So we start by having her click on sign in her app, right? So she's got the TryBank app, clicks on sign in. Today, maybe password manager pops up and autofills, offers to autofill a username and a password. Maybe she types it in manually, doesn't matter. Typically, your bank is going to say, well, that's not good enough. We need to step you up. We want to send you an OTP. So now your bank sends you an OTP, you wait for the OTP, you enter it, and at that point in time, you're signed in. What most apps will then do is it'll offer you some kind of like a shortcut next time you come to the app, right? It'll offer you some kind of like a biometric login, and here we're saying that's cool, let's do the same thing, but instead of calling the native biometric APIs, you'll actually be calling the FIDO API. So that's what we're doing here. Looks very much the same as what you normally would see, but under the hood, we're actually calling into the FIDO module. So we're making a credential on this particular device. Once I've done that, what happened in the background is phone created a new public-private key pair. Public key was sent to the bank, and the private key is kept on the device. Never leaves it, so that's kind of like how this worked. Here is what happened behind the scenes. I'm not going to talk about the code here too much. Like, the slides will be online, I'm sure, and you can look at this stuff later. But essentially what you're doing is you're calling the native FIDO API on Android and saying, make me a new key pair. Very, very simple. Like, the API is really straightforward. There's really just one option you have to set, which is like user verification, which means don't just do this silently, or don't just, allow the user to just touch a button. We need the user to put their finger on a sensor or show their face or type their screen lock in order to make the key, so that we can use it in the future for a password replacement. But, that's kind of like not super important. So you call this in, very simple, makes a key, public key gets into the server. So now the next day, Eliza comes back to the app. What happens? Well, you can just open the app, right? And immediately what will happen is the application will say, okay, now I need to authenticate the user. So what will it do? It'll go to the server and tell the server, give me a challenge. Server sends a challenge to the phone passes the challenge into the FIDO API, which we'll see here in a second. That prompt generates the biometric prompt, and at that point in time, the user is signed in. I don't have the code sample for that, but I think I'll show it later. So it's very much the same thing. Earlier on, we used the create API. This time, we use what's called the get or the sign API. So there's really just two APIs that's important here. Making a credential, you do that the first time, and then every subsequent time when the user comes back, you use the sign API. There's a nice code lab I linked to at the end of the deck here that can kind of take you through the whole process on Android. So you kind of tap this, kind of here, go back here, you tap this, touch your finger, and you're logged in. Straightforward, right? We've all seen this. Everyone can implement this today with what you have available. You don't need FIDO for any of this, but the FIDO benefits, of course, is all of this as abstracted away from you, and you just get the best practices without having to like learn crypto and do any of the other nasty stuff. But the cool thing is the additional benefits you get next time if Eliza opens the website on the phone, right? She goes to trybank.com. You get the same experience. You just open the TryBank app and you can access that exact same key pair that your app put on the phone. That key pair is now accessible from the web as well, because there's a shared context, which is what we talked about. And what happened behind the scenes, here I show basically the get, but this is from the web perspective. So you use navigator.credentials.get, that's a web API, and that allows you to get to that same data or the same key material that you just were able to create on the app. And here's where it gets really cool. What if Eliza decides tomorrow that she wants to go to the same website, but I was do the same property, but she wants to do it from a website on a laptop? So same thing, hit sign in. At that point in time, the idea is that the laptop and the phone kind of share some predetermined state. We can talk about how that happens, but more importantly, the phone is actually close enough to the laptop that these two can have a communication. And if you look very, very much earlier in the deck, when I spoke about like we have this two APIs, the WebAuthn API, and then we have like a API that talks about how a USB authenticator, a security key, gets attached to the laptop. We have an API that we're working on that basically talks about how a phone and a laptop, a phone and a computer, an Android device and a computer, or an Apple device and a computer, an iPhone, it doesn't matter, right? So how these two devices can talk to one another in the background and exchange information. So what will happen, if your phone is physically close enough to your laptop or your computer, it will communicate to this in the background using the CTAP protocol, and the laptop will be aware of all the credentials that you have available for that particular website on your phone. All of the credentials that you just created using FIDO earlier on, either in your app or on the website, it sits on the phone. The laptop can interface with your phone and interrogate it and see, oh, there's a list of credentials. It can display it to you in the autofill credential manager in the browser. There might be a little icon that denotes this is a remote credential. It's not directly on the device. And when you click on this, you'll see a ping on your phone. And this looks very similar to what we usually expect from applications doing like app-based pings on devices. But remember, no app is needed for this to work on the phone. This just comes built into the device already. So the phone pops up and says, hey, there's an incoming signature request for a particular credential that you have on the phone already. Just quickly touch your fingerprint and you're signed in. So no app needed on the device. If the app is there, cool. Maybe the app is how you created the credential in the first place. But the most important part of this is it is phishing resistant. You cannot be phished because there's a local protocol between the laptop and the phone, and everything that we looked at much earlier when we signed over the origin and all that stuff in the physical security key, all of that stuff is actually happening at this point in time as well. So it's almost like your phone is acting as a removable security key to your laptop. So we've looked at 3 use cases so far. The first one is in the app, make credentials and use them. Okay, cool. We can do that today without FIDO. Well, the other thing is we can use the same credential we made in the app on the web on Android. That's not possible without FIDO. And then the third killer use case is once you've made a credential on the phone, now you can access that credential from anywhere, like any other device where there's physical proximity. There's another little thing. These devices need to have some shared state. You need to share a QR code at the beginning to kind of make that happen, but I won't go into that detail. But the pitch here is once you have a credential established on the phone, that credential is now accessible from other places as well. And then there's a fourth killer use case, which we'll look here at in a second. Basically, I think the most important part here is essentially your phone kind of became like a security key plus, right? It's something you just have with you all the time because you have your phone, credentials are on there, and it offers the same kind of phishing protection that physical security keys would offer. So 3 big benefits for using the FIDO APIs. What happens behind the scenes? On the web, you simply call navigator credentials get, and again, you say this parameter that says user verification true. That just means we want an actual fingerprint or an actual, passcode entry or whatever the user does to show, yeah, I own the phone. It's not just someone's random phone lying there. It's actually a phone that the user actively unlocks, and once they do that, the signature is sent back to the server for validation. So Eliza never used a password when signing into her bank on her laptop, even the first time. It just works. So that's kind of like the big pitch. Is it makes things very, very simple. You can really start thinking about how you move away from passwords now. Usually with biometric stuff today, the first time you use a device, you always fall back to a password. That's just how it works. Like first time you get a new phone, get a new laptop, whatever. First time you always have to fall back to passwords. The pitch here is with WebAuthn, you'd never have to fall back to using passwords because your credentials will essentially live forever on your device. But then the $1,000,000 question is, what happens when you lose your device? What happens when the device breaks? Because today, that's the problem. I upgrade my phone, go to a new phone, and I'm back to logging into all of my websites again, or all of my apps again with passwords because I want to re-enable my biometrics. So how do we fix that? That's what this kind of next 2 slides are about. So the thinking with WebAuthn and FIDO on Android is that actually, these credentials that you've created on the one phone will be seamlessly transferred to a new phone whenever you move to another one. Think password manager, right? Password manager is today. You have a password manager, credentials gets set up on one device, seamlessly transitions to other devices. That's currently the thinking that we have, both in Android and in iOS. The thinking is that these things will actually be synchronized. Think iCloud keychain on Android, part of Android Backup Restore. So the thinking is they're end-to-end encrypted, but these credentials will be kind of made available as you move to new devices. So again, the thinking is if you use FIDO instead of the biometric API, if you register credentials in your app on one device and that user moves to a new device, those credentials will be available immediately on the second device. No need to fall back to usernames and passwords again. You can just use the credentials and sign in directly from there. So that's another big benefit of why FIDO kind of outweighs the usability of normal biometric stuff. Of course, it's possible to say in your app you don't want any of this, like you would rather prefer not to move the credential over. That's also possible with certain APIs in here. We kind of recommend against that because it really means all you're going to do is you're going to fool users back to passwords again, which is insecure. So we'd rather have that, transportability remain active, but it's an option for the application depending on the use case. Okay. I need to breathe and drink water. Okay, real-world data. Let's look at this quickly. So this is a web-based use case. It's just because that's where WebAuthn started. But it'll apply directly to the mobile app side as well. There's no reason to believe differently. Of course, we all understand that when you move from passwords to biometrics, things just work easier, right? Users can't forget their biometrics like they forget their passwords. And we'll see that in the next slide with some Google data shortly. That problem just goes away. Also, of course, it's much quicker to just touch a fingerprint or even enter an unlock PIN code on a phone than it is to remember a password and type a password. So in this particular case, hey, no surprise there. By actually moving to biometrics, we reduced the time to sign in by 37.5%, which is kind of like this data from Yahoo. And here's one internally from Google, where we moved away from typing passwords for kind of like use cases where the user needs to step up their authentication. Users finish within 38 seconds, whereas mostly, or in some cases, it took users up to like a little bit over 2 minutes to enter a password. They have to kind of figure out what it is, maybe type it wrong the first time. So clearly it's quicker. But then also one of the other cool parts is this, I couldn't remember my password and I entered it incorrectly. Of course, when you move to biometrics, that just goes away, right? Kind of like a little bit of a shame that both of these are red, but it's not the same red. This is just initialized. I should have used a different color, sorry. Username or at least password kind of forgotten doesn't exist when you have biometrics. Either the user can pass it or they can't. There's no, kind of like, oh, I did it a couple of times incorrectly because I can't remember it and I need to reset it because a biometric just pauses or it doesn't. So that's kind of like a little bit of a case study here. This data, of course, kind of intuitively, we'd expect this data to be like this, right? There's no reason to believe that biometrics don't work easier than passwords. Otherwise, we wouldn't have seen the adoption that we've seen in industry. So almost done. The million-dollar question, of course, is like, okay, this is cool stuff. Like, where is it in actual, in development right now? What can you do? So all of the things, mostly that I spoke about today, is already available. Like on Android, you can already, in your app, make FIDO credentials. On the web, you can make FIDO credentials. You can use FIDO credentials. You can use them between web and between web and an app. All of that stuff works. The usability of a FIDO credential from a laptop to the phone is in beta right now. You can Google it. I can also update my slide and add the link in here. There's a flag you can enable on Chrome on desktop right now to actually enable that kind of linkage to play with. Not out there fully, but it's definitely available to play with. So you can kind of see if you create a credential on the app, like how that credential becomes available to other devices that the phone is kind of like in close proximity to. We have a special protocol that we're working on in the FIDO Alliance there. It's called Cable. It's interesting, it has nothing to do with cables. It's called Cloud-Assisted Bluetooth. But the protocol is actually version 2 of the protocol. We tried a previous one. Bluetooth is kind of like really wonky, so we had some issues there. We moved to a new protocol that looks better. So love to have folks play with that and kind of just tell us how that works. And if everything there works out well, the plan, of course, is to move that into full production. And the idea is also that that protocol will be cross-compatible between Mac, Windows, Chrome OS, like all your different devices. It doesn't matter if you have an Android phone or an iPhone or you're on Windows or Mac or, I don't know, Chrome OS. It'll just work between all of those devices because the protocol is a standard. So all of that stuff is there right now. There's 2 more things that we're kind of like working on that we don't quite have working 100% yet on Android. But the good news is all of the work that I spoke about here today is implemented in Google Play Services on Android. So I'm not sure if you're familiar with Google Play Services, but we have AOSP or Android Open Source, which is kind of like the thing that upgrades every time you get like a new Android version. And usually it's cool that we have new APIs, but it takes a long time for the world to kind of like upgrade to that newer version of Android. Then we have a second interface on Android called Google Play Services, and Google Play Services updates, very, very rapidly, and it updates automatically. And a lot of APIs that's kind of like Google specific, and sometimes like even the third-party stuff gets distributed in Google Play services. FIDO is one of them. So the FIDO module, as we're adding features, automatically becomes available to all phones. This updates all the way back to Android N or Android 7. So automatically, as these features become available, the world just gets them. So in other words, if you were to create a FIDO credential in your app today, and we add functionality later, that functionality will just be accessible to your old credentials you've created. So basically the pitch I want to make is start using FIDO today, because as these features become available, your apps will just get to benefit from them. So there's this thing called discoverable credential support. Basically, it enables use cases where you don't even have to type usernames. You just the credential will just be offered up. Essentially, your app can say, hey, show me all of the credentials available for this user, for this app on the platform, and the platform takes over and shows you a picker. That's kind of like next-gen stuff that we're working on right now, so we want to do that. And then lastly, the full password replacement, the ability to back up and sync credentials from one Android phone to a next. That's not quite there yet, but it's definitely something that we're working on. Timeline-wise, kind of hard to give absolute timelines here, but this is stuff that over the course of the next year or so, those are the types of things that we'll see. And again, should be implemented in Google Play services, which means the technology will just become available whenever we have it, without needing to wait for full Android updates. You can implement WebAuthn today. As I said, most of this stuff is already available. And there is a cool little server with a bunch of test use cases that a good friend of ours have set up over at IBM, how to FIDO at securitypoc.com, nice website to play with. Pretty much on your phone, it should just work because all Android phones and even iPhones, they're all FIDO enabled today. So all of this stuff should work with the local authenticator. If you have a Windows, a low enabled machine, or you have a MacBook like I have with a Touch ID sensor, all of that stuff should just work and you can play with it. You can play with a code lab that we've got set up. So there's a FIDO 2 for Android code lab that you can go and play around with a little bit. And then you can implement you can play with the web-based version of that as well to see how credentials can get shared between the web and between the mobile, the web and between your mobile apps. So both of these two code labs kind of go hand in hand. You can do one, but it's really more fun if you do both of them. Anyway, that is it. I was thinking that I might have a lot of time at the end, but I don't. I have 4 minutes remaining. But I will yield to the floor if anyone has any questions. Sure.
So you said that the credentials, like when you were demoing how it can be transferred over to the laptop, you don't even have to have the app installed to be directly on the phone. So is it like some sort of a password manager built into the system that can handle all these various credentials?
Absolutely. So for the rest of the folks, and maybe also in the video didn't hear, the question is I mentioned that if you have credentials on the phone, you don't even need to have an app installed there necessarily for the credential, because remember that credential could either have been created on the web or it might have been created on a previous device and automatically have been copied over to your new device. So there might not actually be an app associated with that credentials. So yeah, the thinking is that FIDO is, you can either think of it as a second credential manager on the device, or actually what we're pushing towards is a unified credential manager where passwords and FIDO credentials will be offered up alongside each other. So in an app today where you have, when a user clicks on the username field, you have the Gboard or whatever kicking in to say, hey, here's some credentials available. The thinking is that FIDO credentials will also be offered up right there. Now, FIDO credentials isn't just a text field that gets pasted somewhere, so your app will have to have some functionality to understand that, so you'll have to indicate to us when you render a username field that, hey, I also support WebAuthn, so we know that we can offer up these FIDO credentials. But yes, that's exactly it. It is a built-in credential manager into the system, and over time, we'd like to move the password manager to a credential manager, which will be more focused on FIDO than it will be focused on traditional passwords. Yeah, sure. Yeah, absolutely. The initial entering of the password isn't really part of FIDO. It was a way to tell the system that, hey, this is me the first time, and from there on out, we upgrade to FIDO. We see in the future that account creation typically where you give a system the password the first time, that would be replaced with a FIDO create credential operation. So in other words, you come to Google and you say, hey, I want to create a new Google account. And we say, okay, cool, give me your name, give me your last name, click next. Instead of now entering a password, we'll just make you a FIDO credential right then and there. So you'll never have to deal with a password at all for those types of accounts. From day one, you'll be in FIDO land. You can also, for systems that already has maybe a username, you can use like email recovery or systems there where the user doesn't have to enter a password at all. Maybe they'll come in, they'll enter their username, you'll send them a link to their email, and once they click that, you make them a FIDO credential. So the password step is not really a requirement of FIDO in any way, shape, or form, but I think that's going to be a pretty standard way to upgrade and upstep users into FIDO over time, but any mechanism that you have to authenticate that user the first time here can be used instead. Yeah. Yeah, so they're stored in, we're using Keymaster on Android for the storage. So if the device has a TEE or a TPM, and it's interesting, that's why we kind of like I said earlier, it goes back all the way to Android 7. Android 7 was the first time when we had the requirements around like, hey, we kind of want you to have like a trusted execution environment so Keymaster can use it. So the idea is that these keys, FIDO will make sure, but essentially it'll use whatever is the best available on the platform. If you have Strongbox, it can use that. If you have like a Keymaster and backed by TE, it'll use that. So yeah, the idea is that it gets backed up in those types of hardware. Makes things a little bit tricky when we talk about exporting that material to other devices, but there's some thinking in there that we're working on. So that's a great question. I think that this is probably going to be our last one. Yeah, we're just bang on time. So around non-vulnerability, so right now, the FIDO protocol is actually very, very simple, as I explained earlier. So there's not a whole lot that can go wrong there. However, to touch on the gentleman there's question, the big deal here is the private key storage, right? If the private key gets lost, like that's really where the trouble comes in. So what we need to make sure is that, if someone gets hold of your phone and they can spend, a couple of weeks on it with like high-powered lab equipment, yeah, maybe they can get a private key off. And I think that's acceptable for us here. What's not acceptable is scalable remote attacks. Like we don't want to enable the attacks that we see with phishing today, where someone in a different country can just like phish people at scale. That's the type of attack we want to protect against. So if we see issues, and because it's implemented in Google Play Services, if we see a particular issue, we can be very quick to patch and very quick to react to those types of issues. So far, we haven't really seen anything come up yet, but obviously anything that would attack Keymaster or anything on the TEE side would technically be attacking FIDO as well. So those would be the types of things that we'd be looking out for. But we think in general, this approach is a big, like a big improvement of passwords, both on the security and on the usability front. And it's not often that we can talk about security while increasing usability. So we think this is kind of like really a great step in that direction, while we of course need to make sure and balance it out with kind of real world attacks. So it's cloud backed up, so you can back it up again. But if you want to talk more, we can do it. I think we need to end, but happy to talk more. All right, thank you, folks. Appreciate it.